Hello, dear students. Welcome to the chapter 1 number systems for class 9th. Okay, um, I would say this is ABG Tuitions and welcome on board. So, let's begin with what are numbers and what is the number system. Okay, so you have already learned that like 1 2 3 4 are the numbers usually used for counting, and we also introduce 0, okay, our hero number. And here's an example in the NCERT. If you like, I would recommend you to read this. Okay, this is a very informative one, but let's begin our class. So as I was saying, we have numbers. Okay, so in this case, I'll take a number line. Okay, I'll make a line, let's say this, and here I can say that there are numbers starting from 1, 2, 3, 4, 5, and so on till infinity. So these numbers, the positive ones, they are known as natural numbers. Okay, what are they called? Natural numbers. You'll have to tell me, or at least guess, what are they represented with? A letter, a symbol to represent natural numbers. So this was starting from 1, 2, 3, 4, 5, and so on till infinity. Now, when we add a 0 here, so we get our whole numbers. Okay, what are these? Whole numbers. Now you might have heard the term integer. We call these positive integers. 0 is 0, and then we have negative numbers as well, -1, -2, -3, and so on till minus infinity. So when we introduce negative numbers to the number line, what does it become? It becomes our integers. Integers go from minus infinity to infinity. Okay, so we have integers now. Okay, we'll discuss what are they represented with as well. Okay, now in between these numbers are few more numbers. Of course, because this is a number line, if we expand this, there will be many more numbers. Okay, so if I write 1 by 2, this is of the form P by Q, where P and Q both belong to integers. Okay, I'm not writing that right now because we are still yet to do these. Okay, so both belong to integers and Q is not equals to 0. Okay, because they are of the form P by Q, and if Q is 0, then it will become non-determinant. Okay, and we are not talking about non-determinant right now, or indeterminate, whatever you say, whatever you like. So that's why we don't have our Q as 0. Got that? And also P by Q must be such that they are co-prime. Okay, so by co-prime we mean they don't have any common factors. Okay, no, that's no common factors. Okay, so these are our rational numbers. Okay, they also go from minus infinity to infinity. So we have rational numbers. And when we talk further, There are numbers such as root 2, root 3, root 5 for that matter, pi. These numbers, they just keep on going. They don't have a finite value. Okay? So since they're not having any finite value, let me say that's root 3. They don't have any finite value, that's why they are irrational. Not rational, they are irrational. Okay? Irrational numbers. Fine? So irrational numbers also lie on this number line only. They also go from minus infinity to infinity, but they are not rational. Okay? So we have irrational numbers. Fine? Good. So see, I am not using any hi-fi technology here. We are just talking about numbers in this matter. Okay? So natural numbers are represented by n, whole numbers with w. Good one. Integers are represented with z, small z mostly. Sometimes you can also use capital I to represent. Remember, it is capital I. Then when we move forward, we have our rational numbers. Rational numbers is represented with q. Okay? Like in Hindi, we have the word kyun, which is used for logic. Okay? So that's why we have q here. Now moving forward, we have irrational numbers, which are very cumbersome numbers. They are like snakes, and that's why we use s. You'll understand why are we calling them snakes pretty soon. Okay? So irrational numbers are represented with s. Fine? All good? I hope you're making notes. Okay? So all these numbers are together known as real numbers. Okay? Now if we have real numbers, then we definitely have imaginary numbers, and that is for your class 11th. Okay? So now moving forward, what did we learn? We have real numbers. Okay? Real numbers are of two types. They are rational, okay, and irrational. Fine? Now irrational terminates here itself in this matter. And then we talk about rational numbers. In rational numbers, first comes our, what do we say? Integers. Okay? Then we have our whole numbers, smaller than integers. Yeah, smaller bag. Okay? And then we have natural numbers. Okay? So I'll explain it to you once more. What do we have? We have infinite numbers. So this is the entire universe of numbers, let's say. Okay? In this, we have a section of real numbers, because other numbers are imaginary. Okay? These are real numbers. In real numbers, we have, in real numbers, we have irrational numbers. Okay? And we have rational numbers. Inside rational numbers, we have got integers. Okay? Inside integers, we have whole numbers. And inside whole numbers, we have natural numbers. Okay? So let's write it once more. These are natural numbers. These are whole numbers, these are integers, and these are rational numbers. Fine? Okay. So this means that all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers, but reverse is not true. Like all rational numbers are not integers. Okay, for example, if I take 1 by 2, it becomes 0.5, which is not an integer. Okay, 1 by 2 is a rational number but not an integer. But when we talk about 2 upon 2, it becomes 1. It is an integer and rational number as well. Okay. In this case, 2 upon 2 is integer, whole number and natural number, everything. Okay. But when we are talking about integers, if I take minus 1, it is definitely integer but not whole number. Okay. Similarly, minus 1 is not natural number either. Okay, you got that? Awesome. I hope this much is clear. Okay, so let's move forward. I'll tell you how to determine, okay, whether or if a number or fraction is rational or irrational. Okay, so when we talk about the numbers, there are two types, three things happening. Okay, let's start with example. When I talk about 3 upon 3, it becomes 1. So it is terminating. Okay, because it is terminating, that's why it is rational number. Okay, then if I talk about 1 upon 3, it becomes 0.3333 and so on. So 3 keeps repeating. So which I can write as 0.3 bar because only 3 is repeating. Okay, so when we talk about 0.3333 which keeps repeating, we get non-terminating, because it is not terminating. 3 is continuously going and keep on growing. Okay, it is non-terminating, but these are repeating or recurring. Okay, so it is non-terminating recurring number. So that's why it is rational, because we can have some logic. Okay, only 3 will repeat or only something is repeating continuously. So okay, this is rational. Fine. But when we move forward and I have under root 3, okay, so value of under root 3 is 1.73205 and which keeps on going, okay, further and further. So that's why you can say that this is irrational number. Okay, so let me see, I'm trying if it can solve it, otherwise I'll definitely solve it. Anyways, the value is 1.73205 and it keeps on going. Okay, for that matter, pi, okay, it is 3.14 which we know, but it keeps on going. Okay, either you can have a look with the help of your calculator, or we can see here the values. Okay, So value of pi, where is it? That's root, and yeah, where did it go? Not this. This is exercise 1.1. This might be here or here. You see here. Okay, the value of pi and root 2, they keep on going. They never end. The value of pi is here, okay, which is 3.141592653589679323846264338327950, and so on. It never ends. Okay, pi never ends. Okay, similarly for root 2, it is never ending. And root 3, root 5, everything. These numbers, they keep on going, and there is no pattern that we see or say that they are repeating. They're just going on their own. Okay, so what can we say about them? That these numbers are non-terminating, first of all, okay, and as well as they are non-repeating, non-recurring, okay. Okay, so that's why they are irrational numbers. Fine, you got that? I hope you are getting it. So what do we understand? If numbers are if the numbers are okay, so numbers, they can be either rational or irrational. And when we talk about rational numbers, they are non-terminating, repeating or recurring number, okay, or they are terminating. Simple. Termination, like the movie Terminator, which ends everything. Termination means ending, finishing, stopping. Okay, so rational numbers are non-terminating, recurring, or terminating. Okay, and irrational numbers are non-terminating and non-recurring, okay, because they don't reoccur or they don't repeat. Okay, we see that these are repeating, but this is not repeating. Okay, now let's do one thing. Let me just jot down the value of pi from here, from our book. Okay, so let me see if I can copy this. Okay, and and I'll write it here. Oops, we don't want that, right? Leave it. So value of pi is 3.1419, 3.1415. Okay, wait a moment. So value of pi is something 3.14159 and then 26538, 2653 and so on. But when we talk about 22 by 7, what is the value? Okay, let's work together and let's find it out. Okay, what is the value of 22 by 7? It is asking. Okay, solve. You see, it is already 3.143 and that we were getting 142. Okay, but we are not taking this answer. We are here to solve because it terminates. This is a rational number. That's what I want to prove to you. Okay, so let me begin by 22 by 7. 7 threes are, yes, 21. 1 here, decimal, 0. 7 ones are 7. Okay, what do we get? 3. Then this becomes 30. 7 into 4, 28. What do I get? 2 as remainder. Then what do I have? 3. Shall I go for 3? No, I cannot go for 3. I should go for 2. Okay, this will give me 14. I am left with yes, I am left with 6. Moving further, I get 60. Yes, how are we verifying we are correct? The remainder is always smaller than the divisor. Okay, so now it is 60. 7 into 8. 7 into 8 is 56. I get 4, then a 0, then 7 into 5. It will give me 35. I get 5. And then I should write a bit smaller, right? Everything is visible to you. Anyways, so moving further, I have 50. Do I get 50 somehow? 7 into 7, 49 and 1. I am back to here. Okay, I am again getting 10. I write 1. Okay, again I'll have 7 and then again the remainder will be 3, this and this. Okay, I'll again need 4. So what did I get? 22 by 7 is equal to 3. When I don't want you to solve, you will always solve for me. So 22 by 7 is equal to 3.142857. Again 1428. Okay, so that's why we can say 22 upon 7 is equal to 3.142857 bar. Okay, because this is what is repeating, and that's why it is non-terminating recurring number. Okay, so this implies it is rational number. Okay, so what do we understand? Pi is not equal to 22 by 7, but we take it for ease of calculation. Fine? Yeah, fine. We are good. And that's all for today. Fine. If you wish to take classes from me online, okay, personal classes, only one or at most two students at a time, you can contact me here, okay, and this number, or what, only WhatsApp. Okay, it might come under the name of the stars curation, but don't worry, you will find me only. Okay, I hope you enjoy the class. Happy studying.